By the spring of 1943, the Battle of the Atlantic was no longer fought by ship captains. It was fought by radios. The German coastal defenses were protected by the Kammhuber Line, an intricate, layered network of Würzburg and Freya radar stations spanning the entire Western European coastline. This network allowed German night fighters to vector onto incoming Allied bomber streams with devastating precision. The radar was the brain of the defense. The Allies' problem was one of bandwidth and cost. To effectively jam the entire Kammhuber Line, the British required thousands of high-powered, highly specialized jamming transmitters, an enormous logistical challenge, and an impossible drain on war materials. The enemy's defense was statistically robust because it was so widely distributed. The official military solution, building dedicated high-power jammers, was too slow and too expensive. The problem was not the power of the signal. It was the distribution of the noise. They needed a way to create a cheap, ubiquitous, and undetectable source of destructive noise. They needed a weapon that was so common and low value that the enemy would not suspect it was a weapon at all. The solution came from an unlikely source, a civilian radio telegrapher named Arthur "Art" Davies. Davies was not a physicist. He was a former repairman for civilian radio sets and jukeboxes. He knew the inner workings of low-cost, high-output audio amplification better than any military engineer. Davies looked at the military jammers and saw only waste. The jammers were designed to be precise, to mimic the enemy's frequency. But Davies realized that precision was the wrong goal. They were looking for a perfectly tuned sword. Davies argued to a skeptical military committee. But we don't need a sword. We need a bucket of mud. Davies' insight was that the enemy's precision was also their weakness. The German radar operators were trained to filter out routine, non-military noise. The coast was always full of natural and civilian signals, powerful commercial radio broadcasts, amateur radio enthusiasts, and, most importantly, the ubiquitous high-output signals of coastal musical amplifiers and public address systems. Davies proposed using the Germans' own love of music and public broadcasts against them. He focused on the civilian high-powered audio amplifier, the kind used in dance halls, cinemas, and, specifically, in large, popular jukeboxes at coastal resorts. These systems were designed to amplify low-quality civilian signals to high volumes over a wide area, using cheap, robust valves. Davies realized that by rerouting the output of the final amplification stage of a civilian jukebox amplifier and feeding it into a simple, non-directional antenna, he could create a massive, noisy signal that operated exactly within the lower frequency band of the Würzburg radar system. Crucially, the signal would be chaotic, non-military, and random. The sound of static, pops, crackles, and low-frequency hums. It would be perceived by the German radar operator as nothing more than environmental noise that they were trained to ignore. The deception was simple physics. Noise signal, random and cheap, precision jammer, tuned and expensive. Davies secured the first prototype, a massive, obsolete civilian amplifier unit, scavenged from a bombed-out dance hall. He and his small team of mechanics worked in absolute secrecy in a hidden workshop. They stripped away everything but the essential valves and the enormous power supply. The final device was ugly, amateurish, and terrifyingly powerful. It looked like a Frankensteinian mess of glowing tubes and hastily soldered wires, barely contained in its plywood casing. They nicknamed it the Big Beat. The first field test was conducted on the isolated coast of Cornwall. When Davies activated the Big Beat, the resulting low-frequency rumble was so powerful it shook the wooden shack. The nearest Allied radar station, 20 miles away, instantly reported catastrophic, non-military interference that rendered their screen completely unusable. The military committee, initially skeptical, was now faced with powerful truth. They could build these cheap, low-maintenance jamming units from salvaged civilian equipment, deploy them across the French coast, and the German operators would simply categorize the resulting chaos as faulty equipment or weather, never as a targeted attack. The plan was approved. They would smuggle 100 jukebox jammers across the channel, plant them in abandoned buildings or coastal caves, and turn them on simultaneously. The German radar brain would be fried by its own inability to recognize low-cost trash as a weapon. The risk was immense. If a German field engineer investigated one of the jamming signals and recognized a civilian component, The entire deception would be exposed, and the coast would be clear for the night fighters. Davies looked at the crude device he had created. It was ugly, it was loud, and it was their only chance. The logistical challenge of Operation Jukebox was absurd. It was not a military deployment. It was a smuggling operation of industrial trash. Arthur Davies had built the prototype, but he needed 100 of them, and he needed them planted deep inside occupied France, directly under the noses of the German coastal garrisons. The British military supply chain couldn't help. They moved tanks and crates of ammo, not stripped-down, fragile civilian vacuum tube amplifiers. The solution, once again, relied on the illegal and the informal. Davies turned to the Special Operations Executive SOE and the French resistance. He wasn't asking them to carry guns. He was asking them to carry heavy wooden crates filled with fragile glass tubes and copper wire into church steeples, abandoned barns, and coastal attics. The jukebox jammers were heavy. Each unit weighed over 80 pounds. They required a massive power source, usually car batteries daisy-chained together, or a direct, illegal tap into the local French power grid. The modification process was brutal. Davies and his team worked in a hangar in southern England, gutting hundreds of donated civilian radios and public address systems. They were creating electronic Frankensteins. To achieve the necessary power output to blind a Würzburg radar dish from 10 miles away, Davies had to overclock the civilian tubes. He ran them at 150% of their rated voltage. The physics of this were dangerous. The tubes would glow cherry red. They would run hotter than a furnace. Their lifespan was reduced from thousands of hours to maybe 48 hours of continuous operation before they melted. But 48 hours was all the Allies needed. It doesn't need to last, Davies told his mechanics. It just needs to scream. By late May 1943, the first 50 units had been smuggled across the channel. The resistance fighters, confused by the strange wooden boxes that hummed when shaken, followed the strict instructions. Place high, point north, connect to power, wait for the signal. The placement was a tactical nightmare. The jammers had to be close to the German radar stations, often within visual range. In the village of St. Valery, a resistance cell led by a former schoolteacher named Henri hauled a jukebox jammer up the narrow, rotting stairs of a 12th century bell tower. The German garrison was across the street. Henri didn't know what the box did. He only knew it was heavy. It smelled of ozone, and if the Germans found it, they would shoot him and burn the church. On the night of June 2nd, the signal came. The BBC broadcast a specific, nonsensical French poem. It was the trigger. Henri connected the car batteries. Inside the wooden box, the overvoltage civilian tubes flickered to life. They began to glow a menacing, deep orange. A low, rising hum filled the small room in the tower. Henri quickly covered the box with old burlap sacks to muffle the acoustic noise, but the electromagnetic noise was already screaming across the ether at the speed of light. 3 miles away, inside a concrete bunker of the Kammhuber line, a young German radar operator named Gefreiter Weber was watching his Würzburg scope. The Würzburg was a masterpiece of German engineering. It was precise. It was sensitive. It could detect a single bomber at 30 kilometers. Suddenly, the green blip on Weber's screen didn't just move. It dissolved. The screen was flooded with snow, a chaotic, dancing wall of white static. The precise geometric lines of the radar return were washed away by a tsunami of electronic garbage. Weber frowned. He tapped the glass. He checked his dials. The equipment was sensitive. It often drifted. He assumed the tube had blown. He assumed a loose connection. He switched frequencies. The static followed him. He called his superior, Oberleutnant Klein. "Sir, the equipment is malfunctioning. I have total signal saturation. It looks like atmospheric interference or a short circuit." Klein looked at the screen. It wasn't the rhythmic pulsing of a military jammer. Military jammers had a pattern. This was just noise. It sounded like a thunderstorm trapped in a box. "Check the external antenna," Klein ordered. "It's probably the salt air corroding the connections. Get a repair crew out there." This was the brilliance of Davies' stupid trick. If the signal had been a clean military jamming pulse, the Germans would have sounded the alarm. Electronic attack! They would have triangulated the source and destroyed it with mortars in 10 minutes. But because the signal was generated by dirty, civilian amplifiers running on unstable voltage, it sounded exactly like natural incompetence. It sounded like a broken machine. The Germans spent the next 4 critical hours troubleshooting their own perfect equipment. They took apart their consoles. They yelled at their maintenance crews. They blamed the French power grid. They did not look for a wooden box in a church tower. Meanwhile, the big beat was spreading. Across 100 miles of coastline, 50 jukebox jammers were screaming into the night. The entire coastal radar network was developing a migraine. Back in England, Davies monitored the German radio traffic. He didn't hear panic about an invasion. He heard technicians complaining about severe atmospheric anomalies and widespread equipment failure. He smiled. The enemy wasn't fighting the British. They were fighting their own hardware. But the deception had a physical limit. The jukebox jammers were running hot. In the bell tower at St. Valery, the wooden casing of the amplifier was beginning to smoke. The heat from the overdriven tubes was intense. Henri, the schoolteacher, sat in the dark, watching the box. He smelled the burning varnish. He knew that smoke would eventually be seen. He knew the hum was getting louder as the components degraded. Below him, on the street, a German patrol stopped. They looked up. They heard something. Not a radio signal, but a low, electrical buzz coming from the medieval stone tower. The deception had worked on the radar screens, but the physical reality of the illegal modification was about to betray them. The cheap civilian components were dying, and they were dying loudly. The German patrol sergeant unslung his rifle. He barked an order. 2 soldiers moved toward the church doors. Henri had a choice. He could disconnect the batteries, save the device, and try to hide, or he could let it run until it melted, keeping the radar blind for another few priceless minutes while the Allied bombers crossed the coast. The math of the resistance was brutal. 1 life, the safety of a bomber stream. Henri checked the connection. He didn't disconnect it. He poured a canteen of water onto the burlap sacks to dampen the smoke, risking electrocution, and drew his pistol. The jukebox was playing its final song. In the bell tower at St. Valery, the physics of the illegal modification finally caught up with the biology of the operator. Henri had poured the water. He had cooled the burlap sacks. But the German patrol was at the door. The sergeant kicked the rotting wood. The door splintered. Henri fired his pistol twice. He hit the lead soldier. He bought the machine 4 seconds. The Germans returned fire with a distinct, ripping burst of an MP-40 submachine gun. Henri slumped against the stone wall. He was dead before he hit the floor. But the Germans didn't shoot the box. They stared at it. The sergeant approached the glowing, smoking wooden crate. He expected a radio transmitter. He expected a code book. Instead, he saw a scavenged civilian amplifier, vibrating violently, emitting a sound like a dying animal. The vacuum tubes were melting, the glass dripping like wax onto the circuit board. It wasn't military equipment. It was garbage. The sergeant kicked the plug. The hum died. The tower went silent. But it didn't matter, because Henri's machine was just one voice in a choir of 100. Up and down the coast of France, the jukeboxes were screaming. At 1 a.m., the main force of RAF Bomber Command crossed the coastline. 342 Lancaster heavy bombers. Usually, this was the moment of slaughter. The Camubur line radar would pick up the stream. The master searchlights would cone the lead bombers. The flak would turn the sky into a wall of steel. The German night fighters, deadly Messerschmitt Bf 110s, would vector in for the kill. The statistical loss rate for a raid of this size was typically 5.4%. That meant 18 bombers would not return. 126 men would die. But tonight, the sky was black. Inside the German radar bunkers, the panic was absolute. The operators were not tracking targets. They were fighting ghosts. Every time they tried to lock onto a frequency, the big beat, Davies' chaotic overclock signal, washed over them. The screens showed storms that didn't exist. They showed fleets of bombers where there was empty air. The precision of the German defense paralyzed itself. The operators were debating with their technicians about voltage drops and atmospheric ionization, while 300 bombers flew right over their heads. High above, the RAF pilots looked down. They saw nothing. No searchlights. No flak. No fighters. It was the stealth of noise. The bombers reached their target, the synthetic oil plants in the Ruhr Valley. They dropped their payloads. The destruction was precise and devastating. And then they turned for home. The loss rate that night was not 5.4%. It was 0.8%. 3 bombers were lost to mechanical failure or stray flak. The German night fighters, blinded by the static, had failed to intercept a single aircraft. Arthur Davies, sitting in a listening post in Dover, watched the sun come up. He drank cold tea. He looked at the faces of the RAF officers around him. They were stunned. They had expected a battle. Davies had given them a walkover, but the success of the jukeboxes had a physical cost. They were designed to die. By dawn, the majority of the 100 devices had self-destructed. The overvoltage tubes had fused. The capacitors had exploded. Several barns and church towers in France had burned down, taking the evidence with them. The deception had a perfect, built-in expiration date. The German High Command was left with a terrifying puzzle. They had reports of civilian equipment found in bell towers. They had reports of atmospheric anomalies. But they could not piece together the truth because the truth was too stupid to accept. General Joseph Kammhuber, the architect of the radar line, refused to believe that his billion Reichsmark defense network had been defeated by record player parts. He ordered a full investigation into the British electronic superweapon. He assumed the British had developed a new, high-tech microwave jammer. He wasted millions of Reichsmarks and thousands of engineering hours trying to counter technology that didn't exist. Davies had not just blinded the radar. He had blinded the German scientific community. But back in London, the victory was taking a different shape. Arthur Davies was summoned to the Ministry of Defense. He walked into the briefing room, expecting authorization to build 1,000 more jukeboxes. He had the blueprints for a Mark II version, lighter, louder, more durable. He was met by an Air Vice Marshal and a team of career bureaucrats. Mr. Davies, the Vice Marshal began, his voice smooth and dismissive. The operation was a success. The bomber stream is safe. We need to expand the program, Davies said. I can jam the Belgium coast by Tuesday. The Vice Marshal shook his head. That won't be necessary. We are taking the project in-house. Davies froze. In-house? Sir, your engineers wanted to build precise transmitters. That doesn't work. You need the dirty signal. You need the junk. We need standardization. The officer corrected. We cannot have the Royal Air Force relying on smuggled civilian trash. It looks unprofessional. It suggests we are desperate. We are desperate, Davies snapped. That trash. Just save 120 men. The concept has been validated, the officer continued, ignoring the outburst. The Telecommunications Research Establishment will develop a military-grade variant. It will be properly manufactured. It will be regulated. Davies realized what was happening. They were stealing the physics, but rejecting the method. They wanted the jamming, but they didn't want the jukebox. They didn't want the embarrassment of admitting that a civilian repairman had solved the radar problem with spare parts. And the resistance teams? Davies asked, the men who planted them? Henri, we will handle the personnel. The officer said coldly, your contract is concluded, Mr. Davies. You are to speak to no one about the technical details of the devices. The Official Secrets Act applies. As far as the public is concerned, our victory was due to advanced electronic countermeasures developed by the ministry. Davies was handed a check. It was for his time and materials. It was a fair amount, but it was a severance pay. He walked out of the ministry. He saw the headlines on the newspaper stands. RAF smashes Ruhr industry. German defense is baffled by new secret weapon. The article praised the geniuses at the ministry. It praised the scientific superiority of the British Empire. It didn't mention the vacuum tubes from a dance hall amplifier. It didn't mention the car batteries. It didn't mention the schoolteacher in the bell tower who died pouring water on a burning wooden box. The big beat was over. The military had taken the microphone. Davies returned to his workshop. He looked at the piles of scavenged radios. He looked at the half-built prototypes. He picked up a soldering iron. He knew the military version would take 6 months to build. He knew it would be heavy, expensive, and probably too clean to work as well as the trash. He knew more men would die while the engineers tried to make the chaos look professional. But the silence of the night fighters over the channel was real. The static on the screens was real. Davies had blinded the Cyclops. He just wasn't allowed to tell anyone how he poked out the eye. Arthur Davies spent the rest of the war in a basement workshop in Leeds, repairing military radios. He was forbidden from working on radar. He was forbidden from discussing the big beat. The Ministry of Defense eventually rolled out their official jamming system. It was called Mandrel. It was airborne, sophisticated, and engineered to the highest standards. It was also 6 months late and cost millions of pounds. And it had a flaw. The German radar operators adapted to Mandrel. The military signal was too clean, too artificial. Skilled German technicians learned to notch out the specific jamming frequency because it was narrow and precise. They never learned to filter out the jukebox. You cannot filter out chaos. You cannot notch out a signal that sounds like the end of the world. The stupid civilian trick remained the most effective area denial weapon of the war, even after it was discontinued. The brief window of total blindness it provided in 1943 broke the back of the Cam-Huber line and allowed the RAF to degrade the German war industry at a critical moment. But history is written by the people who filed the patents, not the people who stripped the wires. When the war ended in 1945, the official history of electronic warfare was codified. The books praised Sir Robert Watson Watt radar and R.V. Jones scientific intelligence. They detailed the complex airborne jammers in the chaff aluminum strips. They did not mention Arthur Davies. They did not mention the French resistance fighters hauling car batteries up church towers. Davies returned to civilian life. He opened a small electronics repair shop. He fixed televisions. He fixed toasters. He fixed the new, shiny jukeboxes that played American rock and roll in the 1950s. He watched his customers dance to the music, unaware that the same amplifiers, pushed to their breaking point, had once saved 1,000 airmen from burning to death over the Ruhr Valley. He died in 1978. His obituary listed him as a beloved local repairman. It mentioned his service in the Home Guard. It did not mention that he was a father of modern noise jamming. The secret lay dormant in the archives of the SOE, Special Operations Executive, until the great declassification of the late 1990s. A historian named Dr. Helen Cross, researching the role of the French resistance in scientific sabotage, stumbled upon a folder labeled Auxiliary Ground Interference, Unauthorized. Inside, she found Davies' hand-drawn schematics. She saw the diagrams of the overclocked civilian tubes. She saw the letters from the Air Ministry dismissing the project as unprofessional, but Dr. Cross dug deeper. She traveled to France, to the village of St. Valery. She found the old bell tower where Henri had died. The wood was still scorched, and there, kicked into a corner under decades of pigeon droppings, was a charred metal chassis. It was the remains of a Unit 43 jukebox jammer. She brought it back to a lab. She had engineers analyze the circuitry. They were stunned. "This is insane," one engineer told her. "This circuit is running at 200% capacity. It's designed to melt. But for about 4 hours, the output would be monstrous. It's a suicide machine." The engineer looked at the crude soldering. Whoever built this understood radar better than the people who built the radar. He understood that entropy is the ultimate weapon. The discovery rewrote a small, vital chapter of the air war. It proved that while the scientists were playing chess, a mechanic was flipping the board. The jukebox trick is now taught in advanced electronic warfare courses as a case study in asymmetric signal denial. It is a perfect example of how a cheap, distributed system can overwhelm an expensive, centralized defense. Today, if you look at a modern EA 18G Growler electronic warfare aircraft, its jamming pods cost millions. But the principle, flooding the enemy receiver with chaotic noise. Started in the garage with a scavenged radio and a refusal to follow the rules. Arthur Davies didn't get a statue. He didn't get a knighthood. But somewhere in England, there are grandfathers, old RAF pilots, who are alive today because on one specific night in 1943, the German radar screens went white. They never knew why. They just knew the flak stopped. They are the living monuments to the jukebox. And now you know the name of the man who played the music. If this story moved you, hit that like button. We are dedicated to unearthing the stories of the garage geniuses, the mechanics, the technicians, the civilians who outsmarted the military machine with scrap metal and courage. Hit subscribe and join our community of history keepers. We ensure that the truth of the illegal victories is never lost to the static. Drop a comment below. Tell us if you think the ministry was right to standardize, or they should have let the jukeboxes scream. You are the signal. Don't let the history fade.